SAP Intelligent RPA has a reuse concept that spans many layers. It starts from the package concept we have, where all the independent artifacts like applications, screen captures, identifications, data types, and automations can be reused in new automation packages. You then have the SDK packages, which power the activities within an automation, and these are also extensible and reusable for customers. So in this demo, we'll show you how these reusable capabilities can come together to automate a non-SAP application. And for that, the target of our automation is the RPA challenge website, something which is well known and used within the industry. The challenge here is to read a Microsoft Excel sheet containing personal information and then populate those same data fields on the RPA challenge website. The added complexity here is that the page has a dynamic layout, meaning that you can't use a static determination rule to populate the data fields. The website then measures the speed of the automation execution along with its accuracy, and this gives you a good indication of your own automation capabilities. So here you can see the project homepage of the RPA challenge bot we've created. Within the application page, we've captured the RPA challenge website using our generic web connector. We've then captured using various browsers here to show the independence we offer during both design time capture and runtime execution. The different fields in this page, their visual identification, and the automatically determined capture criteria that our smart capture capability auto-suggests are also shown here. Now the smart recorder also confirms that the field in question can be uniquely identified so the citizen developer is sure that they are on the right track. Please note that the application capture offers a simple point and click option with no extra coding needed for the end user. There is also a built-in capability for the tool to support local testing at this stage as well. So let's take a quick look at the source file, a Microsoft Excel sheet. You can see here that it has 7 columns and 10 rows, which are based on a download from the RPA challenge website. The columns represent employees' master data fields like first name, last name, address, email, telephone number, etc. Now if we come back to the automation project and first have a look at the data types to ensure that we can capture the right information. Here we've created a person data type that mirrors the columns of the Excel sheet, and as seen previously, these data structures define the interface of automations, and these can be called either within an automation project or from an API trigger. And the API trigger can be used by an outside entity too, such as a workflow engine that has an automation as a step in a longer process. Now let's look at the reuse automation that can simply open the RPA challenge page and set the values in the field that we've captured from the page. As you can see here, the automation is simply a very straightforward set activity with no complex additions. The input to this inner automation is a list called employees. Using the person data type which we've defined, this is then used as an interface between the Excel read and this RPA challenge Microbot automation itself. Now let's go to the wrapper automation, and this is used to tie everything together. The wrapper automation starts the application, checks if the Excel with data is available in the local folder, and downloads if it is not already available. Then, in a single step, the Excel is read, and the interface variable, which is a list of the type person, is populated. The reusable automation for filling this data into the website form is then called. This transfers the data into the interface to the web form and submits the results. We will now locally test this automation here. To do this, we select the environment to be deployed and then we run it. And once the testing is triggered, the script is downloaded to the local agent and the automation starts. This will first launch the RPA challenge page and see if it needs to download the data file. Once that's downloaded, the data is read and then the automation starts to populate the website content. And as you can see here, the Node.js based runtime is fast, which is a key capability of SAP Intelligent RPA. With no code injection or any advanced techniques, the all-over form filling is finished in just over a second, which is faster than the industry benchmark, and what's more, it's done this with a 100% accuracy rating. As we mentioned, the speed of execution of SAP Intelligent RPA is partially attributed to the lightweight yet powerful Node.js SDK, This SDK provides the runtime code for all activities that the user selects in the Cloud Studio. Now let's take a brief look at how these SDK packages are distributed and bundled with projects to make bots reusable and scalable as part of a core component of SAP Intelligent RPA. Within the SAP Intelligent RPA store, we can see that the packages are available to explore and can be downloaded to a cloud tenant. From here, you can filter to the SDK packages that you want and take a closer look. As an example, if we look at this Microsoft Excel SDK, you can see that there's documentation to support all Excel-based activities. We can also take a look at the PDF-based SDK too. Finally, as the SAP Intelligent RPA SDK is based on Node.js, it's possible that the SAP ecosystem can extend it and onboard the rich Node.js libraries into the SDK and make them available as activities for users. Now let's see how we can convert this automation into a real headless microbot by defining an API trigger. So we're in the package view of SAP Intelligent RPA, and here you can see the RPA challenge bot in a package form. Now let's create a trigger for that. In the Create Trigger wizard, we select the environment and then choose the API trigger type. We then specify the name and description of the API trigger, and then we can see a preview of the JSON API payload, which is automatically generated from the input data type of this automation. Now within the environment view, you can see all the triggers and the packages, and from within the environment you can generate an additional API key that will grant you object level permission for triggers deployed in that environment. You can then copy that key before you test the trigger. Now we're going to use the Postman Client to test this API based trigger and the invocation. Within the payload we have copied the data for the 7-column 10-row Excel file that's expected by the RPA challenge website. Now within the header tab, we place the authentication details provided by the SAP Business Technology Platform and the API key we generated, and then we post this request. A synchronous response comes back, which has the job UUID for the automation run that will not be started by the Cloud Factory. Now we are in the monitoring view of Intelligent RPA, and upon refresh, we see that there is an automation job created by the API trigger, and this is waiting for an agent to be available to distribute and start the job. Now the local agent picks up the tasks and starts the execution. And within under 2 seconds, 70 fields from the API payload are pumped into the dynamic web page with 10 refreshes, and importantly, with 100% accuracy.